Hi everyone, and here's a small video on what you should do if you miss class on Wednesday, January 5th. So of course we started with the do now. There's two questions today in the do now. Make sure you're answering both parts for full credit. The first is, what do the following series of numbers and letters tell us about sugar? That series that I'm referring to is this C6H12O6. Bonus points if you remember what this combination of letters and numbers is called, what the scientific name is or term is for this combination of numbers and letters. And then the second question is, what information does this picture give you about sugar that the formula above does not? Okay, so again, make sure you're answering both parts of that question for full credit. And then today, we have a very similar classwork assignment as yesterday, but this is called 1-5 classwork, reviewing chemical bonding and molecular formulas. So if we open this up, just like yesterday, we have a PowerPoint that is linked at the top that has review slides on several different topics, the types of bonding that we covered right before winter break, molecular formulas, and chemical symbols. So as a reminder, there were 4 types of bonding that we covered before break: ionic, metallic, molecular covalent, and network covalent. This PowerPoint kind of reviews for you how we can predict the type of bonding in different chemical compounds, either by using chemical formulas in the periodic table or by analyzing the properties of the compound. It also reviews some of the properties of each type of bonding, as well as some examples. Finally, we have 2 review slides on molecular formulas and chemical symbols. Molecular formulas tell us information about the atoms that make up a molecule. So not only what types of elements are present within a molecule, but also the number of atoms of each type of element. And of course, the way that we represent the different elements within our chemical formulas is through the use of chemical symbols. One thing I want to remind everyone and highlight on this slide is that chemical symbols always start with a capital letter. So in this molecular formula for carbon dioxide, CO2, I can tell that we're talking about atoms of both carbon and oxygen because both the C and the O are capital. If that O was lowercase, if it said uppercase C, lowercase o, and then a subscript 2, what I would be looking at is a molecule made up of 2 atoms of the element cobalt. So capital C, capital O is carbon and oxygen, but capital C, lowercase o is the chemical symbol for the element cobalt. This is a common mistake that we were making back when we originally learned about chemical symbols in Unit 2, so please just keep that in mind as we're going through today's review sheet. So here is what the review worksheet looks like. Just like yesterday, the titles on each of the tables align with the review slide topics on the PowerPoint. I have a periodic table linked here to help you with the first section, identifying and predicting the type of bonding. I have another periodic table linked here to help you with the questions about chemical symbols. And there's no periodic table needed for the final section on molecular formulas. In class, we went over the first question of each table together, so I'm going to do that on that video as well. If you're in the honors class, your worksheet looks slightly different, but the questions are the same. So the first question right here under types of bonding is, what type of bonding do you predict will occur within titanium dioxide, which is the chemical compound most prevalent in whiteout? So in order to start this question, I need to think about how I could possibly predict the type of bonding. And on our review PowerPoint, I was reminded that there's 2 methods. One, analyzing the chemical formula and using the periodic table. And 2, analyzing the properties of the compound. In this question, I'm not given any information about the properties of whiteout. I might be able to predict some of the properties. I know that whiteout is white. I know that it is a liquid, right? I know that it is sticky, but I don't know anything about the solubility and conductivity, which are the properties that can tell me information about the bonding. So I'm going to have to use method number 1 here, using the chemical formula in the periodic table. So as you'll recall from before break, depending on whether my compound contains just metal atoms, just nonmetal atoms, or a combination of metal and nonmetal atoms, I can predict the type of bonding that's going to occur within that compound. So if I zoom in here, I see 2 different chemical symbols, Ti and O. Those are the 2 different elements present in my compound. When I open up the periodic table that's linked, I'm going to try and figure out whether Ti and O are metal, nonmetal, or metalloid. First, I see O over here in the orange nonmetal section, and of course we know that O stands for oxygen, so oxygen is a nonmetal. And after browsing around for a second, I find Ti here, atomic number 22, in the transition metal section. So Ti titanium is a metal. I have oxygen nonmetal and titanium metal. I can tell then that my compound, titanium oxide, is going to be ionically bonded. So if you're in the honors class, you're going to type out ionic for this first question. And if you are in the general education chemistry class, you're going to highlight ionic as your answer. Okay. The second set of questions just allows us to practice a little bit translating between element names and chemical symbols using the periodic table. So if I open up the periodic table, my first question is asking, what is the chemical symbol for selenium? So I'm going to find selenium on the periodic table. I can see that it's right here. It has an atomic number of 34, and the chemical symbol is Se. Okay, right here, Se. Remember to capitalize the S and make sure that the E is lowercased. I also could have gone the other direction though. If I was given the chemical symbol as Se and asked what element that represents, I could have looked for Se on the periodic table and found the element name underneath. And then finally, we need to do some analysis of molecular formulas. So on the left-hand side here, I'm given a few different molecular formulas. In the second column, right next to the molecular formula, I'm going to start by listing out all of the chemical symbols that I see. So in this first example, I see Ti and O. In this second example, I see C, H, N, and O. And I know that Ti stands for titanium and O stands for oxygen. If I didn't know what these elements stood for, I can go back and use that periodic table that we just had opened to double check. So here, Ti, I can hover over it and see that it is in fact titanium. Okay, and then I'm going to take a look at the subscripts to figure out how many atoms of each element I have per molecule. For titanium, there is no subscript, so that means I only have 1 atom per molecule. And oxygen's subscript of 2 tells me that I have 2 atoms of oxygen per molecule. Okay. Some people in some of the classes were asking what all of the blank rows were for, so hopefully this makes it a little bit clearer. The blank rows in the molecular formulas column are so that you have enough room to type out all of the chemical symbols and all of the element names for each of the elements present in the different compounds. All right, and if you are in one of the regular college prep chemistry classes, that is all that you need to do for today once you finish up this classwork assignment. And the do now, just submit and shoot me a message so that I grade it right away. If you are in the honors course, you have one more short assignment to do. Within your January 5th folder, you also have a short Edpuzzle that discusses the difference between empirical and molecular formulas. And we're going to talk a lot more about empirical formulas tomorrow. This Edpuzzle video just sets you up for that discussion.